You are going to die. That much you know. But there is a theory, built on mainstream physics taken seriously by physicists at MIT and Princeton, that says from your own point of view, you never will. Not that death won't come for you. Not that science has found a cure. But that the very structure of reality makes it mathematically impossible for you to ever experience your own death. And once you understand why, you'll wish you'd never heard of it. In 1957, a graduate student at Princeton University named Hugh Everett III proposed one of the most radical ideas in the history of physics. Quantum mechanics had a problem. Everyone agreed the math worked. The equations predicted experimental results with extraordinary precision. But nobody could agree on what the math actually meant about reality. The standard view at the time was called the Copenhagen interpretation. It said that quantum particles exist in a state of superposition, multiple possibilities simultaneously, until they're observed. The moment you measure a particle, the wave function collapses. One outcome happens, the others disappear. Everett looked at that collapse and asked a question nobody wanted to answer. Where do the other possibilities go? His answer changed everything. They don't go anywhere. They all happen. Every possible outcome of every quantum event occurs in separate, branching versions of reality that can never communicate with each other. The wave function never collapses. It just keeps branching, splitting, multiplying endlessly at every quantum event across every particle in the universe since the beginning of time. This is the many worlds interpretation. And if it's correct, the universe you're sitting in right now is just one branch of an incomprehensibly vast structure in which every version of every event that could have happened did happen. There is a version of you that took every job you didn't take, said everything you held back, made every decision you walked away from, and there is a version of you that is not reading this right now. Because something went differently, somewhere, at some point, in one quantum event among the billions happening in your body every second. The physics community largely ignored Everett's idea for 2 decades. When he died in 1982, a heart attack at 51, legally drunk, having asked that his ashes be thrown in the garbage, the many worlds interpretation was still considered fringe. But Everett died believing something. Something he discussed with colleagues and friends. Something that followed logically from the theory he had built. He believed he was immortal. To understand why, you need to follow the logic one step further than most people go. In the many worlds framework, every quantum event that has more than one possible outcome splits the universe into branches, one for each outcome. The split is instantaneous. Both branches continue. Both are equally real. Now ask a different question. What happens to your consciousness when one of those outcomes is your death? In the branch where you die, you are gone. There is no experience, no awareness, nothing. But in every branch where you survive, you are still there. Still conscious. Still experiencing. Here's the critical point. You can only ever be aware of branches in which you are alive to be aware of them. From your subjective point of view, from the inside of your own consciousness, the only timeline you can ever experience is one where you survived. Because experiencing requires a survivor, this is quantum immortality. The idea, formalized by MIT physicist Max Tegmark in 1998, that if the many worlds interpretation is correct, your subjective experience will always, by necessity, thread through the branches where you live, no matter how improbable that survival becomes. Think about what that actually means. Imagine you're sitting in front of a machine that measures the quantum spin of a single particle. If the spin is up, then nothing happens. If the spin is down, the machine fires. 50-50, pure quantum randomness. You pull the trigger. The universe branches. In half of all branches, you die instantly. In the other half, you hear a click. You survive, you do it again. The universe branches again. Now only 1/4 of all branches contain a living version of you. But in that quarter, you heard 2 clicks. You're fine. After 10 rounds, the probability of any given branch containing a living version of you is less than 1 in 1,000. After 25 rounds, it's less than 1 in 30 million. After 50 rounds, the odds of survival in any single branch are so small they are effectively 0. And yet, in the many worlds framework, there is still a branch where you survived every single one. And from your own point of view, that is the only branch you will ever experience. Because you cannot experience your own death. By definition, this means if many worlds is correct, that you will always find yourself in the branch where you survived. No matter how many times, no matter how improbable, your subjective experience cannot terminate. Not by quantum randomness, not by any mechanism where survival, however unlikely, is still possible in at least one branch. Your consciousness will thread through the eye of the needle, every time, forever. Sounds like a gift. It isn't. Here is where the theory stops being interesting and starts being horrifying. Quantum immortality does not mean you survive intact. It does not mean you survive healthy. It does not mean you survive in any condition you would choose. It means your consciousness continues in whatever branch contains a version of you that is still alive. And as time goes on, as the improbable becomes the only remaining option, the branches that contain a living version of you become increasingly extreme. You survive the car accident, but not without injury. You survive the illness, but not fully recovered. You survive longer than biology should allow, but not in comfort, not in health, not in any form you would recognize as living well. The physicist and philosopher David Deutsch, one of the most prominent supporters of the many worlds interpretation, has written about what he calls the problem of the quantum afterlife, the branches in which you survive at extreme old age, far beyond the biological limit, would require increasingly unlikely physical coincidences. Random quantum fluctuations repairing cells that should have stopped functioning, probability doing the work that biology can no longer do, and from inside that branch, from your point of view, it would feel like surviving. It would feel like just another day. It would feel like you, Hugh Everett III, believed this about himself. He told colleagues his consciousness would always find a path, that the branching guaranteed him something beyond ordinary death. He died at 51, drunk, estranged from his family. 14 years later, his daughter Liz took her own life. In her note, she wrote that she hoped to find her father in a parallel universe. The man who built the theory of immortality died young. And the tragedy that followed, him into death, suggests the idea had already spread further than physics. There is a crucial question that the theory leaves unanswered, and it's the one that philosophers and physicists who take many worlds seriously keep returning. To what exactly is it that survives? When the universe branches, both versions of you continue. Both are equally real. Both have the same memories up to the point of branching. Both would describe themselves as the original. So which one is you? If you survive the quantum roulette machine 50 times, there are billions of dead versions of you across other branches. There is also one surviving version. That survivor has your memories, your personality, your sense of being continuous with who you were before the first round. But from the outside, from the perspective of everyone else in any given branch, the overwhelming majority of branches contain someone who experienced exactly what probability predicted. Your immortality is not a reprieve. It is a statistical inevitability for one thread among billions of threads that end. The others, most of them, the vast majority, did not make it. Is that immortality? Or is it just the last branch experiencing itself as the only branch the way every branch always does? Cosmologist Anthony Aguirre, who has studied these implications carefully, put it directly. It would be foolish in the extreme to let this possibility guide any decision involving life and death. The many worlds interpretation, even if correct, does not give you any reason to feel safe. Most versions of you are not safe. The one that survives does not know it was the survivor until it is. The many worlds interpretation is not confirmed. It is not the consensus view, but it is taken seriously by David Deutsch, by Carroll, by Max Tegmark, by a growing number of physicists who find the alternative, a wave function collapse that nothing in the mathematics actually predicts harder to defend. And if it is true, if the branching is real, and then somewhere in the structure of what actually exists, there is a version of you reading this that has already survived things you cannot imagine, a version that has outlived everyone it knew, a version still threading through improbable branches long after the biology should have stopped, not dead, not free, just continuing. That is what Hugh Everett built. A theory of physics that solved one problem and created something far stranger. A universe in which death from the inside is impossible, and in which immortality looks nothing like what anyone hoped it would be. You cannot die. Not in your own timeline, but you might spend a very long time wishing you could.